you translate that wrong, you might start World War III. That is a case where you want as much expertise as possible, and you want as many fail-safes as possible. And machines today don't offer that in the same way that humans do.
Welcome to another episode of Merging Minds. Our guest today is Christopher Penn. Christopher leads a team of experts dedicated to helping businesses unlock their full potential of their data using cutting-edge solutions. His proven track record of success includes building AI-powered systems that have delivered double-digit ROI for prominent brands such as Cisco Systems, T-Mobile, Citrix Systems, GoDaddy, AAA, McDonald's, Twitter, and many others. Christopher, welcome. Thank you so much for being with us, and very excited about our conversation.
Wow, thank you for having me.
And Christopher, you're the chief data scientist at truthinsights.ai. Can you tell us a little bit about your work at Trust Insights and your focus as a data scientist?
Sure. So we're a management consulting firm. So a lot of my work focuses around the implementation of analytics, data science, and AI. And AI has been a focus since the beginning of the company. Hence, we bought the .ai domain name back in 2018, well before ChatGPT came on the scene. But a lot of the work that I focus on these days is helping folks make the most of the various AI tools, including the current generation of generative tools, and planning for what they are capable of and what they will be capable of moving forward. Literally, the whole landscape of the industry just changed an hour ago. 1 hour ago from the time of this recording. Meta, the company that makes Facebook and a variety of other products, released the LLAMA 3.1 model, which is and they released it as a foundation model size. So the things that you're used to seeing in, say, ChatGPT or Google Gemini or Anthropic Claude, they released a version that you can download and run yourself that is as high or higher quality than the closed models, which is a massive game changer for any company that has wanted to use generative AI tools, but are like, you know what? This is our really sensitive data. I don't want to hand our accounting data to some third party. I don't want to hand our customer list. If you work for like a 3-letter agency, like, yeah, we don't want to hand our national defense secrets to some third party. Now, with a foundation model that anyone can download and run, if you have the hardware to support it, this blows the doors wide open for mass adoption of very capable AI. So part of my role is helping people understand, what is this thing, what are the implications of this or that or the other thing? How do we use them? And how do we get benefit out of them?
Very cool. As far as adoption goes, do you think there's still a very big gap between the hype versus the actual usage, or do you think the actual usage is catching up to the hype?
So it depends. It depends on who you ask and how. Among knowledge workers, the 2024 Microsoft Work Trend Index study showed that approximately 75% of knowledge workers use generative AI tools in some capacity, with or without their company's permission. So adoption, people see the value of having these tools take on tasks that they don't love doing. Like, hey, let's summarize, this month's client report again. If you can get a tool like a chat GPT to do at least the first draft and cut that 8-hour task down to 8 minutes, that's a no-brainer. That's an easy win. Institutional adoption is very slow. So approximately, I want to say it was an MIT Sloan study came out a couple months ago. Something like 7 or 8% of companies have a formal adoption process. So it's very reminiscent of these things. If you remember, back in 2007 and 2008, everyone started bringing these to work. And people were like, and for those who are listening, I'm holding up my phone. People are like, well, we don't have a policy about consumer tech showing up in the workplace. And for a good decade, it took companies a while to wrap their arms and their brains around what it means when every employee is carrying a supercomputer literally in their pockets. Today, we're seeing the same thing with generative AI. Everyone and their cousins like, I understand, at least at a basic level, this thing will save me time and help me do stuff that I frankly don't want to do. And it is companies that are struggling to keep up to say, well, how do we govern this? How do we put guardrails on this? How do we keep our data safe? How do we, and so on and so on and so on. And so that's kind of where things are right now, with the advent of things like big foundation models that are open source, that changes the landscape permanently. Because a company like OpenAI, for example, which by the way is burning cash at a crazy rate, they could go out of business tomorrow, right? And so ChatGPT, poof, gone. However, once you have a foundation model that's available open weights, anyone can download it, and you can set it up in your own server room and run it there. And though even though OpenAI and ChatGPT are gone, generative AI is not.
How much computational bandwidth do you need to run your own server model, your own foundational model, if you're let's say, a 5,000 employee organization?
It depends. It depends on usage. It depends on how much hardware and how much concurrency you want. So when you hear these models, you'll see, for example, in the LLAMA announcement, you'll see they talk about the LLAMA 3.1 model available in three sizes: 8 billion, 70 billion, and 405 billion parameters. That's basically the parameter count in a model is kind of like saying, talk about how large the index is in an encyclopedia, right? Is it a small index? Like, yeah, you're not going to find much. Or is it a really robust index where everything, you can find things really easily? The more parameters, the bigger the index. However, the bigger the index, the more computational power you need. So the 8 billion parameter model, you can run that on a consumer laptop, right? If your computer can play Call of Duty, you can run this generative model and get good results out of it. 5 billion parameter model, you need about $100,000 worth of hardware just to turn the thing on because it is so massive. However, with today's ecosystems, you can have, you know, conservatively, I've seen instances deployed where a single instance can serve like 10 or 15 or 20 employees with heavy usage, and more with lighter usage or with a really good message queuing system. So you could have it, say, maybe a quarter or $500,000 of hardware that you throw at this thing, and then it's yours. It's your company's. And for like a 5,000 person company, you're probably talking what, 50, $100 million in revenue. $500,000, yeah, it's nothing to sneeze at. It's not like you're gonna just light it on fire for fun. But in the grand scheme of things, to have that capability permanently, that's not a bad investment.
Sure. No, from an investment perspective, makes sense. I think it does add a lot to the infrastructure that requires to be managed. Particularly, I mean, sure, you have the advantage of it being, let's say, your own as far as how you manage it and everything like that. But it's not. There's an interesting balance that I find with cloud computing in the sense that if you use services like Microsoft Azure for GPT instances, or if you use whether it could be OpenAI's enterprise usage of their services as well. Unless I'm mistaken, I mean the the security clauses that they offer as far as privacy goes, they're pretty good. At least, if you're able to trust Microsoft and OpenAI, which personally I am. I know a lot of people aren't, but again, I'm just saying that it's, even though it's super interesting to have your own foundational model and there's a lot of excitement around that, me particularly as a user, if you have to ask me, like from an overhead and simplicity perspective, I still prefer being able to pay, even if it's a large monthly bill of my own token usage through Azure or OpenAI, than having to manage all of that infrastructure. Again, as we are, I also run and manage a tech company in the translation space, and whenever we face the question of whether we're going to internalize some of the infrastructure we use in AWS, for instance, or whether we're going to just use it, we always end up, when we weigh everything out together, we always end up deciding to let's say, use cloud infrastructure as opposed to host servers and things like that. But it's interesting. There is a movement for sure as far as like an almost anti-cloud kind of movement, like taking things back. But as far as your perspective goes, what's the actual risk of sharing sensitive data with these models when you're working in their enterprise frameworks? Like not in like a chat response kind of situation as a consumer, but in the enterprise world.
Honestly, it depends on the data, and it depends on how good your lawyers are. With enterprise SLAs, service level agreements with big companies like Google and Microsoft, those are pretty watertight, because companies already trust massive parts of their infrastructure to these companies anyway. So you're like Azure already has your data on it, so adding more AI stuff probably isn't going to change a whole lot because it's already in there somewhere, right? AWS, same thing. If all your data is in Redshift anyway, then feeding it to Bedrock is not really additional risk. Um, but it depends on the data. There is some data that you absolutely positively cannot let out of your control. Protected healthcare information is one set of data where if there's a compromise of any kind, you are in a lot of very expensive trouble.
Mm-hmm.
National security data is one of
Sure.
those things where you just cannot hand it to someone else. Period. End of story. Like, hey, this is the new design for the 2,000-pound JDAM that we've got, and this is the new aerodynamic foils on it. We cannot let anyone else see this. Period. And so those are the kinds of things where no amount of risk is acceptable. So
Sure.
that's the really the use case for your own foundation model is when no amount of risk is acceptable.
Yeah, I still question that in the sense that even if you own your own foundation model, you're still running some amount of risk because you have your employees. You could be
Right.
subject of some kind of social engineering attack. Your
Right.
data is still running some degree of vulnerability. The only difference is that you're owning 100% of the risk, but it's still there, at least in my opinion.
It is still there, but it's no greater than the risk you already have, right? You already have those employees, and they already can or cannot be compromised and things.
Sure.
But the additional risks are negligible in a situation where when you are responsible for all the infrastructure. And to be clear, that is a hefty responsibility, right? It's keeping servers operational, air conditioning and power and coolant and stuff. All that is not insignificant. But for those organizations, they view that as just a cost of doing business because they have to do that.
Yeah, I just still question. I think, we operate a lot in the space where, for instance, a lot of our users are still heavily biased towards desktop applications, for instance.
Mm-hmm.
And they perceive desktop applications as being safer or something in their desktop folder or something local to be safer than cloud-based, basically. And I don't know if you have any stats on that, but my perception and my research shows exactly the opposite. That like most likely, if you have your data on an AWS self-encrypted bucket with separate keys and managed properly, it's more likely that your data is less likely to be breached in that particular bucket than it is within, let's say, your local environment. But why do you think? Do you agree? And B, why do you think people are so biased towards local versus cloud as far as perception of security?
People, I think, fundamentally understand that cloud is kind of a misnomer. It's really just someone else's computer. Right? Cloud is just someone else's computer. And there is an entire generation of folks with hair my color, on the gray side, who remember the 80s and the 90s and the early 2000s when either cloud didn't exist and desktop applications were what you had to work with, or those who have worked in environments where the cloud reliability wasn't there. In 2024 it is clearly, obviously, you have massive things like Google Workspace and Microsoft 365. Those would not be successful if the overall cloud model was not functional. For those folks who have a lower appetite for risk, they probably have a hybrid approach. I do. So I back up stuff onto Amazon Glacier, because it can hold, terabytes of data for pennies a year. But I also have 16 terabyte external drives that I store copies on as well. Because if I have one, there's an old expression from the military: if you have two, you have one. If you have one, you have none. So if you have one backup, you don't have a backup. Right? If you have two backups, you've got one backup, because if Amazon gets bombed, okay, I've still got my disk. If my basement floods, I've still got Amazon, and so on and so forth. And so if you have data that you cannot lose or you cannot risk, you have a hybrid approach. And I think that's the case for all of these technologies. Is the most risk averse organizations will pursue a hybrid approach where, yes, you will absolutely positively use cloud foundation models. It's stupid not to, right? So a tool like Google Gemini has a 2 million token context window. That is a larger context window than any model right now. You can take 2 copies of William Shakespeare's plays, all of them, and put them in one prompt in a 2 million context window AI model. You can't do that with any other model. There's just out of the question. However, There is also a lot of benefit to having Cohere's Command R running locally on your computer for stuff that you just don't want in the cloud for whatever reason. Maybe you write erotic fiction. I don't know. Something that you have there for some use cases. I have this one set of customers that work in highly regulated industrial chemicals and things. Some of the foundation models will not even work with their data because it says you're talking about explosives. Like, well, yes, we are. That's what our company does. And they're like, we won't do that. And so they have to use on-premise models that have been obliterated, which means the censorship removed, just so they can get the benefits of AI because it's such a sensitive topic.
No, that makes a lot of sense. And as far as like interfaces go, do you see people being able to like these large language models to evolve in the sense that people will be able to do a very wide variety of activities and things within that given interface? Or do you think this interface is more likely to be embedded into different kinds of softwares and solutions in a more kind of imperceptible way? How do you see things evolving? Do you see, let's say, just to exemplify, do you see, let's say, people using AI in Google Docs without realizing necessarily that they're working with Gemini or a model behind it? Or do you see people stopping to use Google Docs and working entirely within Gemini?
Yes. I think the answer is yes. It's both. It's not either or. We already see that. You see that with Microsoft Copilot in Office 365. You see that in everything Google makes, that they've put Gemini literally in every place except the one place people actually want it, which is in Google Analytics. So you definitely see that, and you see people using Gemini either in its native form within the Google app itself. You see OpenAI stuff everywhere. For example, you see ChatSpot, which is part of the HubSpot chat interface, that back ends one of the GPT-4 models into that interface, so that you can talk to your CRM. But also, hundreds of millions of people still use Chat GPT. So it is a question of functionality. It's a question of how much time you want to spend doing things like prompting versus having shards of a model that are purpose built. Apple's new Apple Intelligence, when you look at the system diagrams, when you look at what they shared at WWDC, the Worldwide Developers Conference, they've got a really smart architecture for their system where they've got a base model, and then they have all of these LoRa's, low rank adapters, which are basically like plugins that snap in and out per task. And for a lot of the use cases that Apple was showing and demonstrating, you don't know that you're using AI. It's just kind of there in the background, just doing its thing. It's like it's shortening the email, or it's fixing that line or whatever. And so the applications are going to be both. They're going to be, and you will see this also as we start to see really advanced use cases of generative AI, where essentially you're doing programmatic prompting, that machines become semi-autonomous. I mean, you can do that now, but it requires a little bit of effort.
I agree. And as a follow-up, I have a question, Chris. I don't know how familiar you are with our space, but we work in the translation space. And the translation space is interesting to me because it's been already facing the threat of disruption through technology for at least 40 years with the advent of machine translation. So ever since machine translation, even the more archaic models that were just rule-based and then evolving into statistical and rule-based and then evolving into neural, ever since the dawn of machine translation, translators have always felt that they're likely to be replaced at any time, and that they've always faced that threat. And because of that, they've learned to be very resistant towards technology. So they basically learned to treat technology as an adversary. They have to prove that they're better. They have to prove that the technology sucks. They have to, grab every single machine translation epic fail and screenshot it and basically treat it as a competitor. And with large language models, they just stepped in right into place, and it just became, okay, now this is, the post-neural machine translation framework. That's kind of like how most translators in the industry kind of saw it. I guess my question to you is, what do you think are the key things that allow a user to see this technology as a tool rather than an adversary? And how do you get there?
So that's an interesting question because there's a couple of different ways to look at it. In the translation space, if we are perfectly honest, it is an adversary, in the sense that, particularly for the large foundation models, they are extremely good at translation if your prompting is good. So, if you just type translate this text into into Danish, you're going to get kind of a crap translation, right? If you say translate this text into Danish appropriate for business professionals within this industry, localized for the city of Aalborg, um, within this context, and here's the special words, you will get a much better translation. I've done a lot of translation work from English to Ukrainian, because Ukrainian is kind of a funky language. And when the language models spit out the results, they'll say, here's why I chose this, because this idiom is culturally appropriate in Kiev, but it is not appropriate, say, in Donetsk. So the tools can be context aware in that sense, and they can provide very good translation that rivals or beats the average or below average human. Right? And I think that's the important point. An outstanding translator, the best translators in the world, they are still the best. The humans are still the best. The average, the machines are better now, because on average, that's just the nature of the way the probabilities are invoked in these tools. So there is a truth to the idea that these tools can be adversarial. I mean, for example, I used to subscribe to a translation software, and when language models started being able to handle large contexts, I canceled it because I didn't need to pay that money for when a foundation model did a better job than the paid software that I was using, which was, like, to your point, use those older models. For how a person can think of this as something that is less an adversary depends on the relationship, right? So you, as a human being, as a translator, you have clients, you have people that you talk to, the context, and you have much more data human to human than a machine is ever going to have, right? We're on this video chat together. I can see your facial expressions. I can interpret your body language. I can listen to the accent in your voice. I can do all these things that tell me more information than I could pack into a prompt. And so, if I am an expert human translator, I will still translate better. These tools, I think, are incredibly good for human translators to do a couple things. One, they can do really good first drafts, right? That you can then adjust. So if you've got a large corpus that you're working on, like you got to translate this business book, have a machine do the first pass with really good prompting. And second, and this part, some people like, some people don't like, they are phenomenally good second opinions. You say, okay, I'm going to provide you this text that I translated from English into Korean. I want you to check my work. I want you to validate that I didn't make any mistakes. I want you to validate that I did not use any terms inappropriately, that I kept the correct level of formality in my translation. And the tools can go through and they'll highlight verbatims like, this here may not be as formal as you want. This here, and so on and so forth. So these tools can be useful to human translators, even if the translation's human-led, by being a second set of eyes on it and say, like, yeah, I'm not sure about that. And you can look at it and go, no, I'm right. Or you can go, yeah, I'm gonna adjust that.
Yeah, I mean, I agree and also slightly disagree in the sense that I agree that large language models, if properly prompted and with the relevant context, can provide amazing translations. I also agree that they're going to be as good or better than someone average. And I think that, in my opinion, is analogous to a lot of different professions. Like, if all you do as an attorney, for instance, is just, copy and paste different templates, you're not going to have a job as an attorney for much longer, but if you know exactly that little specific part to tweak, because that's going to avoid, major litigation or potential problems down the road, you have a job, right? Even if you make a tiny tweak in a very large project. So the way I see it, the problem is kind of analogous in translation, in the sense that, sure, you can do an amazing rough draft. I agree. You can run different prompts. You can find different kinds of potential issues, flag those issues. But I still think that the problem, at least where we are right now with GPT-4 or Gemini or anything for that initial draft, you still need that expert set of eyes that's going to know exactly, the exact points that need to be changed. Like, we just did a study right now over 4.3 million words, more or less 4.3 million seconds, more or less 40 million words in 17 languages and over 12 different verticals. So from legal to marketing to engineering and so on. And what we've realized from this study is that using GPT-4 plus neural machine translation coming from Microsoft or DeepL or other engines, humans are already at a point where they're making, in the best performing languages, less than 5% edits over what they're getting. And the worst performing languages, they make close to 20%. This is also a function of individual preferences and biases. Like, for instance, certain translators, they like to change a lot for the sake of changing. But still, we're already operating at a 5 to 20% range. But with language and anything else, what I don't know if you agree with this, but even if we're working at a 1% change, the question is, where is that 1% and how do you make it better? And in my opinion, the there's like a direct proportionality where the fewer the number of edits that you make, it's actually harder to know exactly where to edit, why, and how to improve it. I don't know if you agree with that.
It depends on context. It depends on, well, it depends on two things: sparsity and risk. So sparsity is one area where humans still have a substantial advantage because models know what they've been trained on. So take a relatively rare dialect like Sakya. Sakya is spoken in the Sakya Republic, which is a portion of Russia, and even though it's written in Cyrillic, the Sakya language does not have many exemplars. Native speakers who speak it very well, but there's like 70,000 of them. It's not huge, and so when you take any language model and say translate this into Sakya, they do a crap job, right? Because they just don't have enough training data. So that's an instance where if you have a human being who is fluent in that, they will be the standard for a very long time until there's enough training data to help a model understand the structure of that that very unique language. The other aspect is risk, right? So we have all ordered that item off Amazon that has come from overseas and that has come with a translation that would be charitably on a good day would be called word salad, right? And it's clearly translated typically from some dialect of Chinese and English badly. In that instance, a language model translating that Chinese into very pedestrian English is going to be a massive leap forward, and the risk is very low because it's a vast improvement over do not stick this up your nose when they really meant to say like do not smell this. But that's an example where risk is relatively low and the improvement is very, very high. In a situation like you are translating live on the floor of the United Nations Security Council, the risk is very high of a mistake, right? And the risk of that mistake being interpreted incorrectly is very, very high. You translate that wrong, you might start World War III. That is a case where you want you want as much expertise as possible, and you want as many fail safes as possible. And machines today don't offer that in the same way that humans do. So everything comes down to what is the level of risk and what is the quality of improvement for most basic translation tasks. Like, hey, let's turn this manual into this language. A machine's going to do a perfectly adequate job because the beginning text wasn't that good to begin with, right? There's only so many ways you can say, please return your extended warranty card for an additional small coupon. For risk or importance, like if you were an author and you've written a book of poetry, that's going to be very hard for a machine, at least without extensive work, to capture the essence of what you've written in the target language, right? Because there'll be so much idiom and so much cultural context that machines don't know. For example, suppose you wanted to translate some esoteric sapphic poetry, lesbian poetry, from English to a language that like Serbian. You have very few perspectives in the target language that a human would be able to do, but a machine is going to be like, I'm not even sure how to capture the essence, the nuance, the stuff that's in between the lines. One of the things that's really interesting about human language in general is that human language has meaning encoded within language itself. So as language becomes more complex, it creates emergent properties like reason, because you have so much data compacted into very small forms that when we use language, we are actually expressing things like reason that machines don't grasp yet. They're getting there. As models get more proficient, as they're trained on larger corpuses of text, you're starting to see some of these emergent properties. But that is fundamental to human language itself.
This is all super fascinating, Chris, and I agree with what you're saying. I guess what I would consider is in our approach, regardless of like the sensitivity of the topic itself, or the language, whether it's a high resource language or a low resource language, you still have the need to provide users, translators, reviewers, whoever's looking at the text, in a way that, in my opinion, is more natural than, for instance, prompt and responding with a large language model. Because when you prompt and respond with a large language model, sure, maybe you can, let's say, like you said, be super specific in the prompting. Translate this into this language with a business vocabulary for a target audience this age and specifically localized for this city. Okay, sure, you can go crazy with the prompting, and you can also ask subsequent questions. Are you finding any inconsistencies, any things that are hard to understand, and so on. But it's not, let's say, a natural process from the translator's perspective. The translator was used to being able to, let's say, work out word for word, and now they want to be able to interact with these models in a way that is natural to them. Our approach is all about creating a seamless environment where they don't realize they're working this. They know they're working with a large language model, but they don't see it. From their perspective, they're basically getting suggestions from a large language model that's being trained on very specific context. We treat what we define as context as the entire linguistic corpus for that specific segment that a user defines. So maybe it's all of their history of all of their contracts, maybe it's all of their marketing material, maybe it's all of their email marketing. They decide how to batch this knowledge together. So that knowledge gets leveraged. We leverage, for instance, machine translation engines from a syntactical perspective, because we realized that DeepL, Microsoft, not only are they cheaper from a computational perspective, they tend to oscillate less than large language models when translating, particularly, as you mentioned, with use cases where you have very low resource languages or very little training data. But then you get into a really interesting path where, as translators change things that are being suggested to them, the large language model is also learning from their edits, and it becomes kind of like their digital twin. So that's kind of like the approach that we've been taking. And in that sense, even though I agree with you that, yes, maybe a translator could see this as an adversary, because it will, like you said, for many simple use cases, I just need to get this thing translated, I just need to know the gist of it, that's gone for sure, right? But my understanding of language is that language is a living thing, in the sense that it's changing, it's growing, it's evolving. And because of that, the standards of language also change and evolve with it. So for instance, I don't know if you've seen it, if you've experienced something like this, but I've noticed with my writing, for instance, my writing after GPT changed. So before GPT, I was more focused on maybe a few following grammatical conventions, or following certain patterns, or the structure of the text, or sometimes filling text just to make it more wordy or look better. Post GPT, I've become less focused on, for instance, whether or not something is grammatically sound, a lot more focused on whether it feels like it's mine, whether I'm going to communicate to you something that's actually important, whether I'm using the fewest amount of words possible, or whether I'm being wordy. And I think the key point I want to ask you is, in my opinion, the very nature of language is also going to change as these models evolve. You mentioned how reasoning is also an emergent property of language. I'm also asking if you also think that the nature of reasoning may change as well, as a sub byproduct of all this transformation that we're going through.
Oh, absolutely. I mean, language is constantly shifting. Even think we had what the great vowel shift was about 300 years ago, give or take. Take the word name in English, NAME. It used to be pronounced name. That was literally how it was pronounced. And so it's funny if you go back to Middle English and you pronounce it essentially as written, but with a Germanic perspective, pronouncing it with German syllables, that's how Middle English is read, but you had this vowel shift that happened linguistically about, I think it was 300 years ago, give or take, where suddenly things got shorter. You had things moving around the palate. Even now we're having language shifts as languages change, as the world has changed. You're seeing dialects of languages pop up that didn't exist before. You're seeing harmonization and flattening in other places. You look at, for example, in America, the caught merger, where the word caught, like I caught a fish, and the word cot, the thing you lay on, that border is shifting as time goes on, as people migrate from place to place. So you'll hear in a southern accent, where are you going to say, oh, caught, and where'd you go? How was fishing? Oh, caught a few fish, right? You'll hear that change in spoken word. You are seeing language conventions themselves change. These little devices that we have radically change how we write. The question mark goes away a lot of the time now. When you're talking, particularly with younger folks, they don't use a question mark because the question is implicit within the structure of the word itself. Like, I get a text from my kid, "What's for dinner?" No question mark. I don't need a question mark there to know that my kid wants to know what's for dinner tonight. But that's a convention change. Language changes to reflect the reality we have around us because language is a symbolic compression of knowledge. Um, for example, there are some concepts that are atomic in language that you cannot break down further. Take the word apple. If you have never eaten an apple in your life, that word conveys no knowledge. But if you've eaten bunches of apples, and when I say the word apple, you know what it looks like, you have an idea of what it tastes like, it invokes all these other memories within your head that you reconstruct when you evoke that memory and come up with that synthetic memory of an apple based on just that word. So that word is a trigger that activates retrieval mechanisms in your brain that fish out your previous data and reassemble it. Guess what? Language models function exactly the same way. When you prompt a model, you are activating about 4 to 5% of the model called retrieval heads that go out into the latent space of the model, kind of like you going to a library and asking the librarian to go get books in the library, and they come back with stuff and they reconstruct a book in front of you. We and our technologies are more similar than we think. Even though one's made of silicon and has a power switch, at the same time, the way the models work and the way our own brains work are very, very similar. So yes, as language changes, these models will change too, particularly as they ingest training data from if you look at Meta owns WhatsApp, Instagram, Facebook, Threads, etc., which are huge sources of images and videos and audio and text. Google owns Chrome and Google Search and Gmail and so on in YouTube. And so as we provide these model makers with more and more data and they update their models, as language shifts, so do the models.
That's fascinating. And in that regard, do you think that the nature of writing and what good writing means is also going to change, or do you see
Absolutely.
that?
Absolutely. Look at the last century of how things are written. Even look at the last 25 years. I'm not going to get into politics per se, but look at how we look at how political writing is being done today versus the way it was being done, say, in 1995. Yes, you still have the same points of view and perspectives, but the language in which we used to describe contrary positions is very different today than it was 25 or 30 or 40 years ago. Language changes with culture because language is a byproduct of culture. Think about the way that we describe concepts like gender. Gender today is a very, very different and much more nuanced conversation than it was 50 years ago. 50 years ago, there was no such thing as transgender, right? Not in a language sense. There were some very pejorative terms to describe certain people, but the idea of something like queer or intersex or two-spirit or whatever didn't exist. We have new language about an entire portion of our population now that we use. Look at the way that we use that people use the term gay, right? That used to be a pejorative. When I was in high school and stuff, that was an insult. That was like a playground insult where someone's getting their ass kicked, right, for being called gay. Now it's like that's who that person is. They just self-describe that's gay, and as a result, the language changed. Look at how different groups of people. Look at like how Black folks describe themselves now. There are terms that they use that are non-pejorative that other people using them would be incredibly offensive. So language changes with culture. Culture begets language, and the challenge for us as technologists is to ensure that our models and our translations reflect the culture. A real good example, language in Ukraine has changed wildly in just 2 years. Why? Well, because Russia illegally invaded them. And so there is suddenly a massive cultural shift where speaking Russian, even though everyone grew up speaking Russian is basically offensive to a lot of folks because so much misery has been inflicted on their country by Russia. There's this great surge of national pride of speaking Ukrainian and writing Ukrainian, wearing Ukrainian dress like the Vishyanka and stuff, celebrating Ukrainian culture and music. And so if you were analyzing the language used in Ukraine, Russian would vanish as of like mid 2022 as people just stopped using it. And so culture begets language.
That's, I mean, I love it where you're going with that. That's all super fascinating, Chris. And I guess going back to the idea of, now that we've kind of like contextualized this whole conversation around language, now when we think about like all the intricacies of language, how it's changing, how do you see, let's say, I understand that like in many ways, like you described, the translator, yes, maybe they a lot of average translations or basic low risk, those are gone. But you still need linguistic curators. You still need people who make those decisions exactly how you're describing, like looking at a piece of content saying, yeah, that's just too gender specific, or yeah, that's just gonna offend this group of people, or yeah, that's just not gonna communicate well with Gen Zs, for instance. And you need, at least in my opinion, you still need, even if we were working with GPT-5 or 6 or whatever models are about to come, however they're named, like more sophisticated models, more accurate and so on, I still believe that you need curators. You need people who are looking at the content from a human perspective and saying, whether they're happy, whether they're, how it makes them feel, somehow reacting to it, because otherwise language no longer is something human, right? So in that sense, do you still see like the language models and this kind of generative tech as adversarial, or do you see like a new role emerging for translators, for instance, as language keepers or guardians, or however you want to call them?
I mean, there definitely are already linguistic folks whose job is preservation, particularly of low resource languages, right? Keeping languages from becoming extinct, or in some cases, using generative tools to reconstruct languages. So, for example, in the East Coast, most of the East Coast of the United States used to be the indigenous people were the Algonquin. Right. And so the Algonquin language was the parent family language of languages like Micmac and Nipmuc and Pequot and such. And Algonquin itself kind of is, because of this colonist genocide, largely wiped out. But now with generative tools, because language essentially has to be logical and rational for it to work, you're able to reconstruct based on today's current derivative languages like Mashantucket, to be able to go back and say, well, okay, if we have Mashantucket and you have Mohegan and you have this, can we reconstruct what the Proto-Algonquin would have been with reasonable confidence? And so the answer to there is yes. For translators and linguists, there's another more fascinating angle, and that is for them to start understanding that language is software. One of the things that people don't realize about language models is that they are equally fluent in programming code, C, Python, Java, you name it, all these things. But part of what makes them so incredible is that they understand programming syntax and structures and language, the language of programming, which means that you can write software today in plain language, but it functions as software. There's control loops and structures, if else statements and things. You just write them in a native language. Say, if the user says this, then do this. If the user says this, then do this. If the user doesn't give you an answer, then ask them for help. And you can start writing in plain language. When you are doing translation, one of the translation prompts I have that is one of our proprietary ones has essentially a scoring rubric built in that says, here are the criteria by which you are going to judge this translation. Now, here's the text to translate. Here, I want you to generate 3 candidates, evaluate each candidate based on the scoring rubric, and then choose the highest scoring translation. And so the machine, instead of doing one translation, has to by default do several and then evaluate against what constitutes a good translation. This is not written in Java or Python or PHP or R. This is written in English, but the model executes it as though it were actual code. It steps through it and processes, and just watching it on screen is pretty amazing to go, wow, I wrote a computer program and I didn't write a line of actual code. As a translator, Think about what that would mean for you to be able to write your own code that encodes the nuances of how you think about translation. When you build a scoring rubric for what constitutes a good translation, it is based on your knowledge and your experience and what you think is correct. So like, hey, if you're translating it into French and this term is this gender, pair it with these words, because in addition to the correctness from the grammar perspective, there is a cultural correctness. If you're translating into Montreal French versus Paris French, there's differences. There's pretty big differences. And you can encode that into a scoring rubric, and then the model will generate stuff with your knowledge. And then either it can score it itself and choose a winner, or you can score it and choose a winner, saying this is the one that's most aligned to how I think translation should be done. And so those expert translators can use the words you were saying earlier, build digital twins of their unique point of view on how a translation should be done. And then the machines can adopt that, create candidates, and then they can evaluate the candidates and use them.
That's very beautifully put, Chris, and love the way you articulated that. It's definitely aligned with what we try to do as software for translators, and enabling that kind of seamless intersection between how they think about language and how these models operate. But I guess my question to you is, based on everything that you've seen so far. I mean, you have access to a wide variety of industries and wide variety of implementations. And just as I mentioned, it's not just translators who are worried about their future, whether it's attorneys or whether it's paralegals or whether it's clerks or anybody who has a job that could be somehow foreseen as replaceable, is unless they're completely alienated, they're somewhat worried. And I guess my question to you is, what do you think people can do to minimize the risk of becoming obsolete over the next, let's say, 5 to 10 years?
Get really good at using the tools. So here's the example I use. A human being can pick a bushel of corn in about 10 hours, right? It's a lot of work. They're out in the field, yanking these things off the stem, throw them in a bucket and stuff like that. An individual, a human, can drive a John Deere X9 1100 combine and harvest 7,200 bushels in an hour with driving one of these things. It's the same human as a farmer, but instead of needing 1,000 people to clear your fields, you can have one guy listening to podcasts as he drives and the GPS guides him down the field as the machine is doing the work. This revolution happened in agriculture 50 years ago, 100 years ago, when we had steam power and steam turbines and then mechanicals and electrical devices. So today, farming, still a profession, still vitally important because we all got to eat. Making more food than ever, but less than 1% of the people who worked in agriculture do so today because it's so efficient now. They moved into manufacturing and the industrial revolution, and that became the service revolution, the service industries, and eventually became the information revolution. Well, AI is to knowledge work what automation is to agriculture work, where now one person can drive the machine, crank out 7,200 blog posts an hour instead of taking 10 hours to write one blog post, and have a lot of power and influence. And for other folks, that changes the supply chain. And this is a really important point. Just because a machine can now husk 7,200 pieces of corn an hour does not mean that your job is done, right? Because you still have to take the corn and process it and package it and ship it and sell it on the open market. So that from that piece of automation downstream is the rest of the supply chain with content, with translations. Suppose that you're a really good translator. Now you've done 10,000 translations in an hour. Well, what happens after that? They don't just sit on your desk. They've got to be processed. They've got to be sent on. They've got to be, they've got to move on through the pipeline to the end user, which means that you need more people downstream just to deal with this new capability. And so no task is ever in isolation. There's a supply chain before it and a value chain after it. And sometimes the technology change can have disastrous consequences. For example, Eli Whitney invented the cotton gin, which was a mechanical way of threshing cotton to extract cotton from plants. What did that do? It dramatically increased the demand for cotton. What did that do? It created a huge market for slavery, right? It created this awful, incredibly inhumane situation where thousands and thousands of people were torn from their families and have their identities destroyed and were beaten and stuff because of a machine because it created an upstream problem. So part of what we have to think about when we start looking at the use of AI in these industries is what happens upstream, and is there enough demand to keep the same number of people, and what happens downstream once we've built the knowledge product, what happens to it. And that's something that is not just for a translator to solve. That is something for business folks, for knowledge workers of all kinds to figure out, okay, if I can do the work now, do I even have 10x the customers to serve? If I don't, I need more salespeople, right? I need more clients. I need to be able to 10x my sales and marketing just to keep up with what we're capable of these machines. And so that is a big challenge for everyone in every knowledge work field. How do we integrate these tools and be part of either the task or an upstream or downstream task that will be affected by the tool itself? And we don't know what that looks like. There are jobs that are going to be created that don't exist today. A friend of mine is a PhD and is writing like 700 to 1,200 word papers daily, getting paid 80 grand or something just for this task, and they are never going to see the light of day. They are used exclusively to train machines. A company says, I need a paper on this topic. They write a 1,200 word article, and that goes straight into the machine for training. That is a profession that did not exist 5 years ago. And now it does today. You can see even in translation, hey, we need a translator to translate this piece of text into this specific context for this audience so that we can tune a model for that very specific use case, right? I want to speak just to middle-aged Ukrainian women in Donetsk. We need translators who can do just that. That's going to be the challenge, but that's also the opportunity. The opportunity is going to be a massive change in our value chain for every knowledge work task.
That's very clearly spoken, very powerful, and helpful to see change the ramifications both upstream and downstream. And Christopher, thank you so much for all of the insights. This has been amazing, very inspiring too. And if people want to get to know more about you and your work and Trust Insights, where should people go?
Easiest place to go is to go to truthinsights.ai, and you can find everything from there.
Sounds good. Okay, thank you everybody for listening to another great episode of Merging Minds. Thank you, Christopher, for being such a great guest. And till the next time, bye-bye.
Thank you.